This meeting is being recorded.
For problem 24 from chapter 12, we're asked to provide an efficient synthesis for each of the following transformations. So we will go through part A from this question, and we see here if we perform a retrosynthetic analysis, we could have two possible correct pathways for this transformation. We begin with an alkyne and an intermediate product that we could create to form the primary alcohol as our desired product. We could create an alkene intermediate or an aldehyde. So that's what we see over here. We see we start with our alkyne starting material, and then in this first reaction, this could be achieved using hydrogenation and a Lindlar's catalyst. To stop this after only a single addition of hydrogen to our pi bond here. So we'll stop at the alkene if we use that Poisson catalyst. So now that we have our intermediates, we can treat this with a hydroboration oxidation reagent. So we could use borane in tetrahydrofuran in step 1, and then we could use hydrogen peroxide in basic conditions in step 2, and this would accomplish an anti-Markovnikov addition across our pi bond of H and OH, and we want this to be anti-Markovnikov because we want the OH to be installed here and the H over here. So that's what we see in this pathway with an alkene intermediate product. If we chose the route below, we would again start with our alkyne starting material, and then we could perform hydroboration oxidation in step 1 here. So we could use our modified borane, and then we could do or use hydrogen peroxide in basic conditions, and that would create this intermediate aldehyde product. And then from there, after the hydroboration oxidation in the first reaction, then we could perform a reduction using something like lithium aluminum hydride in step 1, and then an aqueous acid workup in step 2. So we see for part A here, either pathway could be chosen, and we could end up with that same primary alcohol product.